Hello everyone, my name is Iboke Samson Valentine, popularly known as Rexam, the Solo Doctor. I am here to bring you the next episode of my promised video. Before I do this, I would like to say a very big thank you for watching the past video, and I am here to give you the next value on solar installation. Like I promised, I will be teaching you the steps that you will take in starting your solar installation from the beginning level to the professional level. And one of the ways to do that is identifying the components, and the major components that are needed for solar installations are 5 key components, which include the solar panel, the inverter, the charge controller, the battery, and the cable. So I'll be taking a note of solar panel to them. When I do that, I will also introduce you to the measuring instrument that you use in determining the load and also the voltage and the current that is needed for the solar system to work. Permit me to introduce you to the simple kit of the solar panel. This is what we call the solar panel. Solar panel is the combination of solar cells that is attached in a particular device like this. This is exactly 6 watts by 6 volts. So here I'll be telling you the types of solar panel we have, and the types of solar panel we have is 2. We have the monocrystalline and the polycrystalline. This is the polycrystalline. Then we have the ways of identifying them. How do we do that? You go to the template or the label in the panel to know where they are. This is the specification of the panel, the 6 watts by 6 volts. Then we have the solar cell, the polycrystalline. We have the diameter, that is the size of the solar panel, which determines the areas and the places you can mount them. So in considering the areas, you have to consider the width and the length, that is knowing the height of this and the size at which you can hang it using your remount. In the same view, there is what we need to specifically discuss, which is the application range. Yes, it is very important you know the range of the panel so that you know the adaptable load that you can apply with it. How do I mean? This is specifically for 6 watts. That means it can charge a battery of 3 to 5 volts. Above it, it will not be adaptable to this. So we have other panels like 12 volts by 30 watts, 20 watts, we have 150 watts, we have 200 watts, we have 300, 400 and above. Some are rated 24, some are rated 12 volts. So, but for you to get a maximum current, you need higher wattage. Then remember that what is required in the installations determines the number of panels that will be required. The number of batteries you are about to charge determines the number of panels that will be needed. Also, I want to tell you that this panel you see here is specifically made to charge your batteries for phone. The 9 volts battery you have, it cannot power it. It can only charge the 3 volts. Your phone battery is specifically 3.7. Therefore, it is compatible with this. It is very compatible with this. Then I want to also tell you another secret on how you can get the voltages that is coming out from this. When the sun is at the intense situation, that means when the sun is at the peak, so there are maximum voltage that this panel can give you. The maximum voltage is specified, which is approximately 7.2 volts. Then for you to get it, you are going to have approximately 1150 milliamps from this particular panel. Then we can determine that by making use of our instrument, measuring instrument specifically when this is not available. Probably as a beginner, you are unable to see this in a panel. Don't worry, you have a means of identifying the features when the labels are not there. And I'm going to show you how you can get that through your measuring instrument this moment. Like I said, your measuring instrument, this is one of the measuring instruments we have. Just like we know that in mechanical, we have what we call wearing balance, we have the weigh bill, we have caliper for measuring the thickness, we have a lot of things that you use in measuring the wire gauge, and a lot of things that you can use to determine the physical things you are seeing. But in electrical and electronics, precisely, there are what we call measuring instruments, and one of those measuring instruments is the metering instruments, such as the multimeter, the voltmeter, the ohm meter, the frequency meter. So all these things are combined in a way that you can actually get the measurement with a device called multimeter. That is why I bring you this today, to show you what multimeter is all about. I'll be teaching you how you can use it and make a professional installations. Before you go ahead to know the amount of current that pass through this panel, you need to have a multimeter. This is exactly what we call multimeter. I have the probe, I have my meter here. Then how do I measure it, or how do I use it? I will be showing you the major components of this particular meter. This is what we call the knob. This is called probe. It's either the probe or the cable. It is actually a cable because it is the combination of wire and the insulator. That's what makes up a complete cable. So here we have the power button is on. Then we have the lights. The light shows the indication once it is pressed in. Then I have a terminal where you can connect your probe. For instance, you are about to measure voltage, you are to use the terminal for the voltage. Then if you are to measure the ohm meter, you are to use the ohm side. Then if you are to measure the current, because this particular meter is clamp meter, if you are to measure the current, you have to use the clamp. You use the clamp to determine the current that flows along the cable. Then if you are about to measure the voltmeter, what you do is, first of all, you select your knob to the voltage side. Remember, we have two types of voltage. We have the DC volts, then we have the AC volts. Then in DC volts, when we talk about the DC voltage, we are talking about the voltage from the battery, we are talking about the voltage from the sun, we are talking about the voltage from the panels. So all these things are DC volts, just like the battery, the voltage in your battery. For instance, your cell phone is DC, the one in your laptop is DC, the one in your mic is DC, then all those ones from the panel is DC. But when we are trying to measure them, we select the knob to a particular place called the DC side. So if I bring it here, I'm measuring the DC. And don't forget that when measuring this, you are measuring according to the specific voltage that is required. And the maximum at which this multimeter can handle is 1000 volts in DC aspect. Then because it is DC, you can measure from 0 to 1000. Above that, it will not be compatible with the voltmeter, which might cause a damage to this particular meter. So please, if you are gaining value in what I'm writing, don't forget to subscribe. Samson Valentine in YouTube. Then we are also going to measure the AC voltage. The maximum AC voltage that this can handle is 750 volts. When I say AC, I'm talking about the alternate current and the alternate voltage. So you actually know that anything that is gotten from the inverter output is the alternate. So like I said, the maximum at which this can handle is 750. Then I'm equally going to show you how you can measure the current. The current is rated, assuming you want to get a current of 20 to 15. So what you need is you select your knob to 20 amps. Select your knob to 20 amps. Then if you are to measure 200 amps or 20 and above, so you select it to 200. Above 200, you can get it to 1000, which is the maximum current that this particular multimeter can handle. And remember that in measuring the current, you only use the clamp side. You use the clamp side. You see how open it is? So you measure it by passing the cable in between. So in the same way, if you want to measure the voltage, let's say we are now going to measure the internal resistance or the resistivity or the continuity of a conductor. So we are going to use, here is the common or the ground. When we talk about ground or common, we are talking about the negative side of the battery. So you connect it here. If you are to measure the ohms, we connect here. Remember, when I'm talking about the ohms, I'm talking about a parameter. As the parameters we are determining is the resistance, we determine the current, we determine the voltage. Those are the parameters we are determining with this. Then the frequency also. Then here, I'm going to measure the continuity of this particular cable. If I get it right, there will be a sound that the buzzer will give me. That sound indicates that the cable is true. There's no blockage in between them. There's no cut along the line. Everything is intact. Therefore, whatever thing that flows from here will be gotten here. Whatever thing that flows from here will be gotten here too. There is no cut along the line. So I'm going to select it to the ohm meter side. Now it is in the position of the ohm. Sorry, I didn't tell you this on time. This is hold. This hold is actually used to show probably after your measurement, and you don't want it to go out of the display until you take your record. All you need to do is to press this hold and it will remain there. So now it is in ohms. I'm going to measure the continuity, listen and hear the sound. Can you hear it? This simply means that the probes are okay. There is no cut anywhere. So assuming I want to measure the current, I will remove the two probes. But if I'm about to measure the voltages, what do? I have to interchange this from here and connect it to the voltage side and select my voltage. Here, anything I measure should be in volts. The moment I do that, the display or the screen will show me DC as a selected parameter that I'm working on. Then if I'm measuring AC, if I select AC, it will be shown AC as the parameter I'm working on. If I'm measuring the current, it will show as the parameter. Likewise in the ohms, it is in the buzzer side. See, the buzzer will indicate. Then if I'm about, remember I told you that we can use it to measure the frequency. We can use here to measure the frequency. We can equally use it to determine the earth leakage. Probably you have in your house the appliances that are causing electrocution, such as shock when you touch the body. All you need to do is to bring this parameter and trace the fault using this. So I will be teaching you in my next video on how you can identify the leakage or earth leakage system in your environment or also in your house. Permit me to bring you the next video when next we meet. Please, if you have not subscribed, click on the subscription button, Samson Valentine in YouTube, and subscribe. as I'll be dropping you more values about solar installation. Thank you.